Somewhere, something incredible is waiting to be known. Carl Sagan. The universe usually announces its secrets with explosions, supernovas, colliding galaxies, black holes devouring stars. But this mystery arrived in complete silence. Almost 12 billion light-years away, astronomers discovered a galaxy that seems to have broken the rules of cosmic history. No dramatic burst of energy, no violent collision, just a massive, ancient galaxy sitting quietly in the darkness, as if it had finished its entire life story long before it was supposed to. And that's a problem, because according to everything we thought we knew, this object should not exist. To understand why, imagine finding a fully grown oak tree in the middle of a desert where the first seeds were planted only a few months ago. You wouldn't just question the tree, you'd question the entire history of the forest. That's exactly what astronomers are doing right now. The discovery came from the James Webb Space Telescope, humanity's most powerful machine for looking into the distant past. And when I say distant, I mean ancient. The light from this galaxy began its journey toward Earth nearly 12 billion years ago. Those photons started traveling through space before our sun existed, before Earth existed, before there was anything here to receive them. By the time this light reached the golden mirrors of James Webb, it carried a message from an era when the universe itself was still young, an era that cosmologists thought they understood. For decades, scientists believed the early universe was a chaotic construction site. Galaxies were supposed to be messy, violent, rapidly growing, producing stars at extraordinary rates. Everything should have been noisy and unfinished. Instead, JWST found something astonishing. A galaxy that appears old, mature, and strangely quiet, almost as if it had already lived most of its life. Astronomers checked the data, then they checked it again. Simulations were rerun, measurements were reanalyzed, yet the conclusion remained the same. The galaxy is real, and its existence creates one of the most uncomfortable questions in modern astronomy. How could something so ancient, so massive, and so calm exist when the universe itself was barely out of childhood? Because if this galaxy truly is what it appears to be, then somewhere in our understanding of cosmic history, a page may be missing. And before we can understand why this silent galaxy is causing such a scientific headache, we need to travel back to a time when the universe looked nothing like this at all. A time when the cosmos was a gigantic construction site filled with fire, chaos, and newborn stars. So what exactly did the universe look like in its violent childhood? A quiet, ancient galaxy shouldn't have existed, because the universe it was born into looked nothing like a retirement home. It looked like a construction site on fire. Imagine arriving at a city that's still being built and finding a perfectly preserved museum already standing in the middle of it. That's the problem astronomers are facing. To understand why this galaxy is so disturbing, we have to travel back 13.8 billion years. Back to the beginning. The Big Bang wasn't an explosion in space, it was the expansion of space itself. At first, the universe was unimaginably hot. No stars, no planets, no galaxies. Just a dense fog of energy and particles. Then the cosmos began to cool. After about 380,000 years, the first atoms formed, mostly hydrogen, a little helium, and then darkness. For hundreds of millions of years, the universe was almost empty. Astronomers call this period the Cosmic Dark Ages. No starlight, no galaxies, just enormous clouds of gas floating through a black ocean. Then gravity got to work. Tiny differences in density became cosmic seeds. A slightly denser region attracted more gas. That extra gas created more gravity. And slowly, the first stars ignited. They were monsters. Some may have been hundreds of times more massive than our sun. And they lived fast, a few million years. Then they exploded. Those explosions forged new elements. Carbon, oxygen, iron. The ingredients that would one day make planets, oceans, and eventually people watching YouTube at midnight. The universe became busy, very busy. By roughly 1 billion years after the Big Bang, some galaxies were creating stars at astonishing rates. In certain cases, astronomers estimate that more than 1,000 stars could form every single year. For comparison, Our Milky Way only produces around 1 or 2 new stars annually. The early universe was a cosmic factory running 24 hours a day. Nothing about it suggested peace. Nothing suggested maturity. Nothing suggested a giant galaxy that had already finished growing. According to our best models, galaxies during this era should have been messy teenagers, rapidly changing, still assembling, still feeding on enormous reservoirs of gas, certainly not old, certainly not quiet, and definitely not nearly motionless. Which is why the discovery from James Webb felt so strange. It wasn't simply that astronomers found a big galaxy. They found one that seemed to have skipped its entire childhood, as if someone opened a history book and discovered that Chapter 10 had somehow appeared before Chapter 3. But here's the question that made scientists even more uncomfortable. How did we even find this impossible object in the first place? After all, this galaxy is nearly 12 billion light-years away. Its light is older than our solar system. So how can humanity possibly see something so distant, so ancient, and so faint? To answer that, we need to meet the machine that was built to do exactly one thing: travel through time without ever leaving Earth. To solve this mystery, we need to meet the machine that found it. A machine built to do something that sounds impossible. Travel through time, not with wormholes, not with science fiction, but with light. Every time you look at the moon, you're seeing it as it was about 1.3 seconds ago. Look at the sun, and you're seeing the past by roughly 8 minutes. Light needs time to travel. The farther away something is, the further back in time you're looking. Astronomy is the only science where observing something also means looking into history, and no machine has ever been better at that than the James Webb Space Telescope. Launched on Christmas Day in 2021, JWST began a million-mile journey away from Earth. Its destination was a gravitational parking spot called L2, a place where the combined pull of the Earth and the Sun allows the telescope to stay cold and stable. Cold matters. Because Webb doesn't look at the universe the way your eyes do. Your eyes see visible light. Webb sees infrared, heat, ancient, stretched-out light from the earliest galaxies. As the universe expands, light travelling through it also stretches, like drawing a line on a balloon and then inflating it. The line becomes longer, the light becomes redder. Eventually it slips completely into infrared. That's why older telescopes couldn't see some of the earliest galaxies. They were looking with the wrong set of eyes. JWST was designed specifically for this challenge. Its giant gold-coated mirror spans more than 21 feet across, large enough to collect incredibly faint light that has been travelling for billions of years. Think about that for a moment. Some of the photons striking Webb's mirror tonight began their journey before Earth even existed. Those particles crossed expanding space for almost the entire history of the universe, only to end their journey inside a telescope built by a species that learned to fly barely a century ago. That's astonishing. And then came the images. Within months of becoming operational, JWST started revealing galaxies that looked older, brighter, and more developed than anyone expected. At first, astronomers wondered if the telescope was wrong. Maybe the data was contaminated. Maybe the computer models were mistaken. Maybe the distances had been miscalculated. Because the alternative was uncomfortable. The alternative was that the universe had kept a secret. Then one particular galaxy appeared, a massive object nearly 12 billion light-years away, ancient, quiet, and somehow mature. JWST wasn't showing scientists a simulation. It wasn't showing an artist's reconstruction. It was showing reality, a message sent directly from the ancient universe. And that message seemed to say, "You don't understand me as well as you think." The discovery immediately created an impossible problem. Because this galaxy wasn't merely old, it appeared to have already finished growing, as if an adult had somehow appeared in a universe that was still in kindergarten. And when astronomers calculated just how massive this object really was, the mystery became even deeper. How could a galaxy become fully grown before the cosmos itself had even reached its second birthday, an adult galaxy in a universe that was still in kindergarten? That was the impossible picture staring back at astronomers. At first, researchers thought they had made a mistake. Maybe the distance was wrong. Maybe the galaxy only looked massive. Maybe the computer models had fooled them. Science loves mistakes, because mistakes are usually easier to fix than reality. But the numbers kept surviving every test, and those numbers were astonishing. This galaxy appears to contain roughly 100 billion times the mass of our Sun in stars. That's in the same league as our own Milky Way. The problem? The universe was less than 2 billion years old when the light left this galaxy. To put that into perspective, imagine meeting a 25-year-old person in a world that has only existed for 6 months. Something doesn't add up. According to our current models, galaxies grow slowly. They pull in gas, form stars, merge with neighbours, grow larger, repeat. It's a cosmic version of building a city one brick at a time. Even under ideal conditions, creating a galaxy this massive should take billions of years. Yet this object seems to have done it in a cosmic sprint. It somehow gathered enormous amounts of gas, converted much of that gas into stars, then stopped. That's the strange part. The galaxy doesn't just appear old, it appears retired. Astronomers call such systems red and dead galaxies. Red because their stars are old and cooler. Dead because they've largely stopped making new stars. It's the equivalent of finding a bustling city and discovering that all the construction workers left centuries ago. But how could that happen so early? The first stars in the universe didn't even appear until a few 100 million years after the Big Bang. That leaves an incredibly small window of time, a cosmic deadline that seems impossible to meet. Some researchers propose that the galaxy may have experienced a period of unbelievably rapid growth, a star-making frenzy, a cosmic factory running at maximum speed. But even that explanation struggles, because making stars is hard work. You need enormous amounts of gas. You need gravity to pull everything together. And most importantly, you need time. The universe doesn't usually hand out shortcuts, yet this galaxy seems to have taken one. It's as if nature secretly discovered a faster recipe for building galaxies and forgot to tell the textbooks. The discovery made astronomers uncomfortable, because one strange galaxy can sometimes be ignored. But one strange galaxy that breaks the timeline of cosmic history, that's different. That forces questions. Maybe galaxies in the early universe grew faster than we thought. Maybe our simulations are missing important physics. Or maybe the early universe behaved in ways we still don't understand. Then researchers noticed something even stranger. Something that transformed this galaxy from unusual to genuinely bizarre. Because galaxies are not just collections of stars, they're giant spinning machines. And this one appeared to be doing something almost impossible. It wasn't spinning, at least not the way a galaxy this massive should. Imagine finding a giant windmill standing perfectly still in the middle of a hurricane. You wouldn't ask why the windmill exists, you'd ask why it isn't turning. And that question would open an entirely new mystery. Galaxies are giant spinning machines. This one seems to have forgotten how. That may sound like a small detail. It isn't. It's a little like discovering an ocean with no waves, or finding a clock whose hands never move. The entire identity of a galaxy is tied to motion. Our own Milky Way rotates at roughly 220 kilometers per second. The Sun is currently hurtling around the galactic center at nearly 800,000 kilometers per hour. And we don't even notice. Almost every large galaxy in the universe spins. Some slowly, some rapidly. But they spin. So, when astronomers measured the movement of this ancient galaxy, they expected the same thing. Instead, they found something deeply strange. To understand how they measured it, imagine listening to an ambulance. As it approaches, the siren sounds higher. As it moves away, the sound drops. Light behaves in a similar way. It's called the Doppler effect. If one side of a galaxy is moving toward us, its light shifts slightly. If the other side is moving away, the light shifts in the opposite direction. These tiny changes reveal how fast a galaxy is spinning. It's an incredibly reliable method. Astronomers have used it for decades. Then they pointed it at this galaxy, and almost nothing happened. The shifts in light were remarkably small, far smaller than expected for an object this massive. Independent teams checked the numbers, then checked them again. The result stayed the same. By astronomical standards, the galaxy was nearly motionless. That created a second mystery. Because even if scientists somehow explain how the galaxy grew so quickly, they still have to explain why it barely rotates. Where did all its angular momentum go? That's the scientific term for an object's tendency to keep spinning. If you've ever watched an ice skater pull in their arms and spin faster, you've seen angular momentum in action. Nature guards it carefully. It doesn't simply disappear, which means something extraordinary must have happened. Perhaps the galaxy experienced violent mergers. Perhaps interactions with neighbouring galaxies somehow slowed it down. Or perhaps our understanding of galaxy formation is missing an important piece. No explanation fits comfortably, and that's what makes discoveries like this so exciting. Science doesn't advance when everything makes sense. It advances when reality refuses to cooperate. This galaxy is doing exactly that. It's behaving like a witness who answers every question with another mystery. Old, massive, quiet, and now almost motionless. By this point, astronomers were no longer dealing with a single anomaly. They were dealing with a stack of impossibilities balanced on top of one another. A galaxy that formed too early, a galaxy that stopped making stars too soon, a galaxy that barely spins. The deeper researchers looked, the stranger the picture became. So they did what scientists always do when confronted with the impossible. They started building explanations. Lots of them. Some involved giant collisions. Others involved supermassive black holes. A few even hinted that something about the early universe itself may have behaved differently. But every idea eventually crashed into the same problem: the clock. Because no matter how creative the explanation became, one question refused to go away. Did the universe actually have enough time to create this impossible galaxy at all? By now, astronomers had a problem. Actually, several problems. A galaxy that formed too quickly, a galaxy that stopped making stars too early, a galaxy that barely spins. So they did what scientists always do when reality behaves strangely. They started building explanations. Lots of them. The first idea sounded reasonable. Maybe this galaxy was built through repeated mergers. Galaxies collide all the time. The Milky Way itself is on a collision course with the Andromeda Galaxy. Cosmic crashes are part of the universe's normal routine. If enough smaller galaxies smash together rapidly, perhaps they could create one enormous mature system. It was a clever idea. Until astronomers looked at the clock. The universe simply wasn't old enough. To build a galaxy this massive through mergers would require an astonishing number of collisions in an incredibly short period of time. It's like trying to build New York City in a weekend by merging thousands of villages together. Possible on paper, almost impossible in practice. So scientists looked elsewhere. Another theory involved a monster, a supermassive black hole. These giants sit at the centers of most galaxies. Some contain billions of times the mass of our Sun. When black holes feed, they can release enormous amounts of energy. Enough energy to blast gas out of an entire galaxy. No gas means no new stars. The galaxy effectively shuts down. Perhaps that's what happened here. Perhaps a giant black hole acted like a cosmic leaf blower and cleared the galaxy of its star-making material. Again, it was an interesting idea. Again, the clock ruined everything. Because to have a black hole powerful enough to do this, you first need time to grow that black hole. And time is exactly what the early universe didn't have. Then came a more radical possibility. Maybe the problem isn't the galaxy. Maybe the problem is our understanding of the early universe itself. Some researchers began exploring whether dark matter behaved differently shortly after the Big Bang. Dark matter is one of the strangest ingredients in the cosmos. It doesn't emit light. It doesn't reflect light. In fact, we can't see it directly at all. Yet, it seems to make up about 85% of all matter in the universe. Think of it as an invisible scaffold. Galaxies form inside its gravitational framework. If that scaffold behaved differently in the young universe, galaxies may have grown much faster than our models predict. It's a fascinating idea. But there's a problem. Dark matter is already one of the biggest mysteries in physics. Using one mystery to explain another mystery can feel like trying to repair a watch with a second broken watch. Theories piled up, papers were published, computer simulations ran for thousands of hours. Yet every explanation eventually crashed into the same wall: time. The universe wasn't giving astronomers enough of it, and then researchers calculated a single number. One number that transformed this puzzle into a genuine crisis. the age of the stars inside the galaxy. Because if those calculations were correct, then this impossible galaxy didn't just grow too quickly. It may have begun building itself almost immediately after the universe turned on the lights. And that possibility would force scientists to ask a deeply uncomfortable question. What if the early universe evolved much faster than we ever imagined? Sometimes an entire scientific mystery comes down to one number. This was one of those times. Astronomers estimated that the stars inside this galaxy are approximately 1.5 billion years old. At first glance, that doesn't sound shocking. After all, our Sun is about 4.6 billion years old. The universe itself is 13.8 billion years old. So why did this number send cosmologists into panic mode? Because of when the galaxy is being observed. The light from this object left it when the universe was only about 2 billion years old. Do the math. If many of its stars are around 1.5 billion years old, then those stars must have formed when the universe itself was only a few hundred million years old. That's astonishing. It's the cosmic equivalent of finding a fully written novel only minutes after someone invented the alphabet. According to our previous models, that era should have looked completely different. The universe was still in its infancy. The first stars had only recently ignited. Galaxies should have been tiny, chaotic, primitive, not mature systems containing tens of billions of stars. Yet the numbers refused to change. Researchers reanalyzed the data. They reran the computer models. They tested different assumptions. Again and again, the result survived. That's when the mystery evolved from a strange discovery into something much larger. Because this wasn't just about one galaxy anymore, it was about time itself, specifically whether our timeline of cosmic evolution is incomplete. Imagine archaeologists digging into ancient soil and finding a modern smartphone. You wouldn't simply question the phone, you'd question the entire timeline of human history. This galaxy is astronomy's version of that smartphone. It doesn't fit where it's supposed to be. Some researchers have suggested that star formation in the early universe may have been dramatically more efficient than we thought. Maybe galaxies could build themselves at incredible speeds. Others wonder whether the first stars appeared earlier than our models predict. A few even ask a more uncomfortable question. Could some of our assumptions about the young universe be wrong? Science doesn't fear these questions. In fact, science depends on them. Every major revolution in astronomy began with observations that didn't fit. The Earth wasn't supposed to move around the Sun. The universe wasn't supposed to be expanding. Most of the cosmos wasn't supposed to be made of invisible matter and mysterious energy. Yet reality didn't ask for permission. And perhaps this galaxy is doing the same thing. Perhaps it is pointing toward a chapter of cosmic history that we haven't read yet. Or perhaps it is simply reminding us of something scientists often forget. The universe is under no obligation to make sense to us. But the story gets stranger. Because age isn't the only unusual thing about this galaxy. It also appears completely exhausted. Its star factories have shut down. Its gas reservoirs are nearly empty. Its brightest days may have ended billions of years ago. In other words, this ancient object doesn't just look old, it looks dead. And that raises another question. How does a galaxy become a cosmic graveyard before the universe itself is even young? A galaxy that formed too early would already be strange. A galaxy that formed too early and then died? That's something else entirely. When astronomers looked more closely at this object, they noticed something missing. Gas. In the universe, gas is everything. Hydrogen and helium are the raw ingredients of stars. No gas means no new stars. It's like finding a bakery with no flour, no sugar, and no ovens. The building still exists. But the baking has stopped. This galaxy appears to have almost completely run out of fuel. Its stars are old and reddish. There are no bright stellar nurseries. No giant clouds collapsing into newborn suns. No signs of active star formation. By cosmic standards, it is remarkably quiet. Astronomers sometimes call galaxies like this red and dead. It's a dramatic name, but it captures the idea perfectly. The galaxy is still there. Its stars still shine, yet its most important era may already be over. Think about our own Milky Way. Every year, it creates roughly 1 or 2 new stars. That may not sound impressive, but it means our galaxy is still alive, still changing, still writing new chapters. This ancient galaxy seems to have stopped writing its story billions of years ago, and that's deeply confusing, because galaxies in the early universe should have been overflowing with gas. The cosmos was young, fresh material was everywhere. Star factories should have been running non-stop. Instead, this galaxy looks like an abandoned city, a place where all the lights are on, but nobody is building anything anymore. Even stranger, once star formation stops, something important also stops. Chemistry. Stars are cosmic furnaces. They forge heavier elements like carbon, oxygen, and iron. Every atom in your blood was once inside a star. Without new stars, the chemical evolution of a galaxy slows dramatically. Its composition becomes almost frozen in time. This galaxy may be one of the closest things we've ever seen to a true cosmic graveyard, an ancient monument left behind by an era we don't fully understand. And for a while, scientists hoped that maybe this object was simply an oddity. Every field of science has outliers. Sometimes nature just likes being weird. Maybe this galaxy was the exception. Maybe it won some kind of cosmic lottery. Then JWST kept looking, and that's when the story became far more unsettling, because this galaxy isn't alone. Over the past 2 years, the telescope has started finding more ancient red galaxies in the early universe. Some are even farther away. Some appear equally mature. Some seem just as impossible. One strange object can be ignored. 2 become interesting. 3 begin to look like a pattern. And patterns are dangerous, because patterns force scientists to ask a frightening question. What if this isn't an anomaly at all? What if the universe has been hiding an entire population of impossible galaxies? Because if that's true, then astronomers may not be dealing with a small error in their models. They may be standing at the edge of a scientific revolution, and revolutions in science always begin the same way, with observations that refuse to behave. The most dangerous discoveries in science are rarely alone. They bring friends. For a while, astronomers hoped this strange galaxy was simply an exception, a cosmic oddball. The universe is full of weird things. Pulsars, black holes, rogue planets wandering through interstellar darkness. Perhaps this ancient, quiet galaxy belonged in that category. Then the James Webb Space Telescope kept observing, and the universe answered with something unsettling. More galaxies, more ancient systems, more red, mature objects appearing far earlier than anyone expected. One impossible galaxy can be dismissed, an entire population cannot. Suddenly, astronomers found themselves asking a completely different question. What if these galaxies aren't anomalies? What if they're normal? That possibility changes everything. Imagine historians discovering a single smartphone in ancient Rome. That would be bizarre. But if they found thousands of smartphones scattered across the empire, they wouldn't question the phones anymore. They would question history itself. That's where cosmology may now find itself. Over the last 2 years, JWST has identified several surprisingly mature galaxies in the early universe. Some appear massive, some seem to have stopped making stars. Some form so quickly that existing simulations struggle to reproduce them. Each new observation adds another piece to an increasingly uncomfortable puzzle, because modern cosmology is built on timelines, the first stars, the first galaxies, the gradual assembly of larger structures. Everything is connected like chapters in a book, but these galaxies seem to have skipped several chapters entirely. It's as if the universe turned the page while astronomers were still reading the introduction. Of course, scientists are being careful. Extraordinary claims demand extraordinary evidence. Distances can be refined, measurements can improve. Some of these galaxies may eventually prove less extreme than they first appeared. Science is patient, it doesn't rush to declare revolutions, but it also doesn't ignore evidence, and right now, the evidence is pointing toward a possibility that few people expected. The early universe may have been far more efficient at building galaxies than our models predict. Perhaps stars formed earlier. Perhaps gas collapsed faster. Perhaps some ingredient of cosmic evolution is still missing from our theories. Or perhaps the universe is preparing to teach us another lesson. that our understanding of reality is always incomplete. History is full of moments like this, when astronomers first realized the Milky Way wasn't the entire universe, when they discovered that the cosmos was expanding, when they learned that most of the universe is made of substances we cannot even see. Each revelation forced humanity to redraw its map of reality. This could become another one of those moments, or it could turn out to be something smaller, a correction, a refinement, a detail hidden inside the mathematics. Right now, nobody knows. And that's what makes this story so exciting, because we are watching science happen in real time. The questions are still open, the debates are still unfolding, the answers have not yet been written. The next generation of observations may tell us whether these impossible galaxies are a small wrinkle in our theories, or the first signs of a scientific earthquake. And that leads to the biggest question of all. If the universe truly evolved differently than we imagined, what else might be hiding in the darkness, waiting to rewrite our understanding of the cosmos? Somewhere, something incredible is waiting to be known. Carl Sagan said that decades ago. This galaxy may be one of those incredible things. Nearly 12 billion light-years away, an ancient object sits in the darkness. Massive, quiet, almost motionless. A galaxy that appears to have finished its life story while the universe itself was still young. And right now, nobody knows exactly why. That's what makes this discovery so important. Not because it proves our theories are wrong, not because it destroys modern cosmology, but because it exposes the edge of our understanding. Science is often portrayed as a collection of answers. In reality, it's a map of questions. Every generation believes it has nearly completed the picture. Then the universe reveals another blank space. A century ago, we didn't know other galaxies existed. A few decades later, we learned the universe was expanding. Then came dark matter. Then dark energy. Today, we know that everything you can see, every star and planet and galaxy, makes up only about 5% of the cosmos. The rest remains mysterious. History suggests something important. The universe has a habit of being stranger than we expect. This impossible galaxy may be another reminder. Future observatories are already preparing to investigate. The Nancy Grace Roman Space Telescope, the Vera C. Rubin Observatory, and of course, James Webb itself. Each new observation will bring more data, more measurements, more clues. Perhaps astronomers will discover that these ancient galaxies are rare exceptions. Perhaps new physics will explain them. Or perhaps we are witnessing the beginning of a much larger shift in our understanding of cosmic history. Nobody knows. And that's okay, because uncertainty isn't a weakness in science. It's the engine that drives it. The greatest discoveries often begin with an uncomfortable sentence. We don't understand this. That's where black holes came from. That's where quantum mechanics came from. That's where entire revolutions in physics began. This silent galaxy may eventually become just another solved mystery, or it may force humanity to rewrite part of the story of the universe. For now, it remains exactly what it appears to be, a contradiction, a message from the ancient cosmos written in a language we don't yet fully speak. Think about that. A collection of stars so distant that its light began travelling toward us before Earth existed has managed to confuse one of the most advanced civilizations in history. There is something beautiful about that, because it reminds us that the universe is still wild, still unexplored, still capable of surprising us. And perhaps that's the most exciting part of all. The cosmos is not a book we've finished reading. It's a library whose doors have only just opened. And somewhere in those endless shelves, more impossible galaxies may already be waiting for us to find them.